Hi, this is video 3 where we're looking at the playlist on the Edexcel November 2017 higher tier paper. And in the previous video we completed through to question number 17, so we're going to start this video from question number 18 onwards. Please do stop the video, have a go at each of the questions and then compare your solution. Hi, so on to question number 17, where it says prove algebraically that the sum of that and that is always a square number. So basically what we need to do is sum these two things together. So in other words, we're going to say, well, we've got a half n plus 1, and we're going to add that to a half n plus 1 times n plus 2. So it looks a little bit daunting when you look at things like this, but what we're going to do is just take it a stage at a time. Okay, so the first thing is that I've got this half n and it's multiplied by n plus 1. Okay, so I'm going to multiply the first term. That's going to give me a half n squared, because n times n is n squared. And then I've got a half n times plus 1. Well, that's going to be just a half n. Okay, then the next little bit, what I'm going to do is deal first with these two brackets multiplied together, and then finally I'm going to multiply by the half. Okay, so I'm going to ignore this half for the moment, but I'm going to multiply n times n squared, plus 2n plus n plus 2. Okay, so when I tidy that up, what I'm going to end up with is a half n squared plus a half n plus a half, and then brackets n squared plus 3n plus 2. Okay, so the last little bit then is we need to multiply out this by this half. Okay, so I'm going to rewrite this again, half n squared plus a half n, okay, plus a half n squared. Okay, now a half times 3n is actually 3 over 2n. So it's entirely how you write this. I would tend to prefer 3 over 2n, but if you preferred, you could write it as 1.5n. It really wouldn't make any difference. I just tend to prefer fractions myself. And then I've got finally a half times 2, which is plus 1. So again, it still looks a little bit untidy, but now it's going to hopefully start making sense, because we've got a half n squared and a half n squared. Pull those two together, I'm going to get n squared, which is great. Then I've got a half n squared plus 3 over 2. Oh, sorry, beg pardon. I've got a half n plus 3 over 2n. It's this one here plus this one here. So 3 over 2n plus a half n. Well, I can write that as 3 over 2n plus a half n is going to be, the denominator is the same, which is 2. That's 4 over 2n, which is 2n. Or if you prefer, you've got 1.5n plus 0.5n, which is the equivalent to this one here, and that's also going to equal to n. So it doesn't matter whether you work in decimals or in fractions. So I'm going to get n squared plus 2n, and then finally I've got this 1 at the end. Okay, so what we're being asked to do is to prove that it's always a square number. Now, it is a 2-mark question, so it's a little bit undervalued on this, because you've got to recognise that actually if I factorise this term, I'm going to get n plus 1 times n plus 1. Okay, hopefully you can see that becomes two terms that when you multiply them together gives you n squared plus 2n plus 1. So actually what we're saying is that this is exactly the same as n plus 1 squared. Therefore it must be a square number. All right, so hopefully that's okay for you. You've been able to follow that through. There are some examples on the playlist on the channel that might be able to help you with these sorts of questions. 18, And in this particular question, we've got to enlarge shape P by a scale factor of -1/2. Okay, well, the easiest way for me, I think, is to use vectors, because essentially what we're saying is that we've got 3 points. The official kind of maths word for this is vertex. So we've got 3 corners, one of which I'm going to call A, and then I've got B, and then I've got C, okay, and each of those have got coordinates. So coordinate for A is going to be 2, 3, okay, coordinate for B is going to be 4, 3, and coordinate C is going to be for 2, 7. So what we do is we take each of those coordinates and then we multiply them by a scale factor of -1/2. Let me explain to you what I mean. So if I go to the very bottom of the page here, what I'm going to say is I've got A, so this is coordinate A, and that is a vector 2, 3. So in other words, with A, what I'm doing is that from the center of enlargement, which is 0, I'm going along 2 and then up 3. Similarly with B, from the center of enlargement, I'm going to go along 4 and up 3. And similarly with C, along 2 and up 7. So I can write those actually as vectors. So A is 2, 3. Now if I multiply that by -1/2, what I'm actually going to get is -1 and -1.5. Okay, hope that's all right for you. So 2 times -1/2 is -1, and 3 times -1/2 is -1.5. Okay, so I'm going to use the same principle for B. Okay, with vector B, I'm going to go along 2, beg your pardon, I'm going to go along 4 and up 3, so 4, 3, okay? Again, if I multiply that by -1/2, okay, I'm going to go along -2, and then I'm going to go down or up -1.5, okay? So that would be B. Let's look then at C, okay? Well, the vector to get to C is along 2 and up 7, so that's going to be 2 and 7. I'm going to multiply that by -1/2, so my new vector is going to be -1 and -3.5. And basically, it's a case of taking these new vectors from our center of enlargement, okay? So what I've got here is if I go from 0, and I'm going to go now to A, so I'm going to go along -1 and down -1.5. With B, I'm going to go along 2 and down -1.5, okay? And with C, I'm going to go along -1 and down -3.5. So what I actually get now is my new triangle, which is here, okay? Now, what might be useful sometimes is you can actually draw in the lines, what are called the lines of enlargement. So if you can see, hopefully, that because this vector has been enlarged through 0, 0, I can actually join all of these points to the corresponding points, and they will actually go through 0, 0. So this one here will go through there. This one, it's a little bit tricky on the video, but hopefully you'll be able to see what I'm doing. We'll go through here, and this one will go through here. Okay, so hopefully that's okay for you, and we'll give you some idea of how we work with negative scale factors. If you're not sure about any of these things, please do have a look on the channel, and there is a playlist that has quite a few examples of this type of question. Okay, let's move on then to question number 19. We're about 4 or 5 minutes into the video or so. Please do stop the video, have a go at this question and see how you get on. Okay, so we've got A, B, C, D, and A, E, and B are points on a straight line with the equation of that. Okay. Well, really, I would stop at that particular point, because that's not really good enough for what we want. What we normally want with equations is that they're in the form y equals mx plus c. So the whole idea with that is that m gives you the gradient and c gives you what's called the y-intercept. But nevertheless, I do want to make y the subject, okay? And this is a bit of a favourite trick with these sorts of exams, is that they tend to give you the equation where it's not quite set up in the way that you want it to be. So it's worthwhile just stopping, having a go, and making sure that you get things set up. Because if I make y the subject, I can take the x over, which means I get y equals minus x plus 12, or rather 2y. If I divide through then by 2, I get y equals minus a half x plus 6. So actually that's what they mean. They mean that the line AEB, which is AEB, goes through the y-axis at plus 6. So this point here is 6, okay? And that the gradient of the line AEB is minus a half. Okay, well it actually then allows us to pick up a few more bits of information. So the other bits of information is that when y, which is this on this equation here, equals 0, it will allow us to work out the value of x. So in other words, when y is 0, so I've gone along the x but not gone up, y is 0, it will allow us to work out the value of point B just by plugging in y equals 0 on this equation. Okay, so I can write when y equals 0, okay, I've got 0 equals minus a half b, minus half x plus 6. Okay, so if I minus 6 from both sides, I get minus 6 equals minus a half x. Okay, divide through by a half, or minus a half, I get a minus divided by a minus as a positive, therefore x equals 12. So what it's now telling me is actually this point B is 12. Okay, so hopefully you're following this okay. Now, they are quite tricky, but you will notice that actually, even at this point, I've really not got past the second sentence, or rather the second part of it, where they've given me all this information. They've given it for a specific reason, because it allows me then to work out the value of specific points, which might be important to me. Now, I know it is good to actually read the whole question and go from there, but I think from my point of view, I like to just take it a bit at a time to see if I can figure out what it is they're asking me to do and why they're giving me the information. Because one of the important things now is we're being asked to work out the equation for m. Okay, well, the equation for m is going to be important to me because or rather not just important to me, but what I've got already is I know that y equals mx plus c for the equation m. Well, what I've found out already is that the gradient of m, which is this line along here, is perpendicular to the gradient for AEB. So if it's perpendicular, it means that it's the negative reciprocal. Okay, that's important, that basically minus a half, if I multiply that by minus 1, I get that y equals 2x plus c. So the gradient of m is going to be 2x on this particular line here. Okay, so that's the first bits of information that I've actually got. Okay, so there's other things that I can find out. Well, I do know that, as I mentioned before, this is 12. I know that this is 6. Okay, so what I'm going to do then is I need to look at point A. Okay, so if I look at point A, which is one of the points on the line that I've got a little bit of interest in. Well, what it tells me is that AE equals EB. Okay, so Right, let's just look at that. AE equals EB. All right. So, in other words, what we mean is that if this is 6, then it means that there is also a further 6 jumps, so this must be 12. Okay? Hopefully that's okay for you. All right? It also further tells me that if this line along here is 12, then this line along here must also be 12. So this point here is minus 12. Okay, so that's a little bit tricky as a concept to cover, but hopefully you can see as you work through these things that what we've got there is the word is congruent. It's triangles that are exactly the same. Okay, and if we know that this hypotenuse is the same as this hypotenuse, we know this is 12, then it means this line here must be the same as this line here. So this must be minus 12. Likewise, this line here must be the same as this line here. Okay, so if this is 6 jumps, and this must be 6 jumps, so that must be 12. So therefore, we can, from the information, calculate that at point A, that the value of x is going to be minus 12 and the value of y is going to be 12. Okay, so now we've got all the component parts that we need in order to work out the equation for M, or the equation for the line DAM. Okay, so if we have the standard form, it's y equals mx plus c. What we've said is that we know the gradient is 2. So we can write y equals 2x plus c. And what we've got there is two values, one of which is x and one of which is y. So I can simply plug these two values into this equation and work out the value of c. And once I've got that, I can just then write the equation for m. Because I can say that when y equals 12, x equals minus 12 plus c. So 12 equals minus 24 plus c, okay? Add 24 to both sides, I get 36 equals c, okay? So now I've got both the gradient and the c values. This is my c value, this is my gradient, so the answer to this question is y equals 2x plus 36. Okay, that's quite a tricky question. As I mentioned before, there's a number of quite difficult questions in this particular exam, but hopefully you've been able to follow that through. I think on the channel there is there are some videos that might help you to get some extra practice with these sorts of questions, but it's worthwhile looking at the equation of perpendicular lines on a straight line graph. There will be some similar questions in that. Okay, let's move on to an equally tricky question, which is where we're actually going to look at question number 20. Okay, so on to question number 20, which is probably one of the more difficult questions on the paper because we're dealing with cosines and we're actually being asked to work out the value of y when x equals 45. But it also means we're going to work out the value of A and the value of B, and we need to also know the cosine values for some of the x values here. So before I actually get into that, what I'm going to do is I'm just going to create a little grid, which might be helpful. Now, the way I do it is I work out sine and cosine kind of simultaneously for each value of 0 and then 30, 45, 60 and 90. Now we won't need all of these, but it's just kind of what it's doing is it's helping me to put my mind thinking about the different cosine values. Okay, so the way I'd write it is root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, and then backwards. So it's root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, and then root 0 over 2. Okay, so I've now got cosine values of each of the angles. So for instance, if I wanted the cosine value of 30 degrees, it would be root 3 over 2. Okay, so let's move on then back to the actual question itself. And it allows us really to pick out the ability to be able to create a couple of equations that we can sort of work with in order to isolate the values of A and the values of B. Okay, so what I'm going to do is I'm going to have a look at the situation when y equals 3. Okay, so let's have a look at the actual equation. Y equals A cosine x degrees plus B. Okay. So when y equals 3, x equals 0, okay? So when y equals 3, I've got A, and then the cosine of x degrees. Well, the cosine of 0 is root 4 over 2. Well, root 4 over 2 is the same as saying 2 over 2, which is the same as saying 1. So I can write that as A. This little dot just means times. So cosine of 0 degrees is 1 plus B. Okay, so I've got 3 equals A plus B, and that's one of the equations that I can now use. Let's have a look at another situation when the value of y is 1. Okay, so at this point I can also do exactly the same idea to be able to find out, if I can, these two values of A and B, which are important. Okay, so this is, if you like, the first situation when y equals 3. The second situation is when y equals 1. So I'm going to write that again. 1 equals A. Now I've got cosine of, in this particular case, 90 degrees. So again, I go along to my chart and I've got 90, okay, 90 degrees is the same as saying root 0 over 2. Well, that's actually 0, okay, so this is 0, so it means the cosine of 90 degrees is 0, so I've got A times 0 plus B. So therefore, 1 must equal B. Well, that's excellent because now it allows me to work out my values of A and my values of B. Okay, so my third sort of case is that I've got 3 equals A plus B, and I know that 3 equals A plus 1, therefore A must equal 2. All right, hopefully that's okay for you. So now I'm in a position where actually I can put all of this together to be able to write the value of y when x equals 45 degrees. Okay, so let's write now the actual equation. Y equals A cosine of x degrees plus b. Okay, well, y equals A I know is 2. And the cosine of 45 degrees, well, again, if I go back to my chart, I've got 45 degrees, that's root 2 over 2, okay? So root 2 over 2 is the cosine of 45 degrees, okay? And then B, I know, is plus 1. All right, so we just need to simplify that up a little bit, that if I've got 2 times root 2 over 2, I can get rid of those 2's. So the answer to this particular question would be y equals root 2 plus 1. Okay, so it takes a little bit of working through those sorts of questions, but hopefully you were able to follow that one. They are quite challenging. There are some examples on other exam papers, but they don't come up too often. But although it is worthwhile certainly getting to grips with writing out ratios, in whichever form you actually do that. Okay, let's move on then to question number 21. And we'll make this the last question of this particular video. I think I'm actually going to do 4 videos for this paper because we've got 2 questions right at the very end which might need a little bit of explanation as well. Okay, so question number 21. Show that that can be written in the form of that, where a and b are integers. All right, so it's one of those situations where really you just need to follow a method through. So I've got 6 minus root 8 divided by root 2 minus 1. Okay, well, the easiest way to get rid of this denominator is to multiply it by root 2 plus 1, because that will have the effect of getting rid of this root 2. But because I've multiplied the denominator by root 2 plus 1, I've got to multiply the numerator by root 2 plus 1. All right, so let's see how that works out for us. So I'm going to do the denominator first, the bit at the bottom first. So I've got root 2 times root 2 is going to be root 4, and the square root of 4 is actually 2. And then I've got root 2 times plus 1 is 1 root 2 minus root 2, so that's going to cancel themselves out, and then a minus 1 times a plus 1 is a minus 1. Okay, now I did that really quickly. There are quite a few examples on the channel of how to actually get rid of these sorts of denominators and multiply them through effectively by completing the square. So I didn't really want to spend too long on this video going through that sort of thing, but hopefully you've been able to follow that. Please do have a look on the playlist for other examples. Okay, let's have a look at the 2 at the top first. Next, so 6 times root 2 is going to be 6 root 2. Okay, and then 6 times plus 1 is going to be plus 6. All right, now I'm now going to multiply by minus root 8. So minus root 8 times minus 2 is going to be minus 16. Okay, well, the square root of minus 16 is going to be, or the square root of 16 is going to be minus, and then square root of 16 is 4. Okay, and then finally I've got root 8 times plus 1, minus root 8 times plus 1 is minus root 8. All righty, so again, a little bit tricky, but hopefully if you've spent a bit of time with working through these sorts of things. I'm also very aware that you might have a slightly different way of doing the multiplication to me, but you should come up with broadly the same sort of answer, where we end up with 6 root 2 okay, right, so I've got minus 8 here. Well, that minus 8 is the same as saying root 4 times root 2, which is the same as saying 2 root 2, because I've got now 2 root 2 and 6 root 2. So 6 root 2 minus 2 root 2 is going to be 4 root 2. And then I've got plus 6 minus 4 is going to be plus 2. And then it's all divided by 2 minus 1, which is 1. Okay, so that would give me a final answer of 4 root 2 plus 2. Okay, all right, I hope that's okay for you. These questions are a little bit trickier to work through, but hopefully you'll be able to follow what I've done with this root 8 in order to simplify everything through. I've said that it's the same as saying root 4 times root 2, and root 4 is 2, so it'll be 2 root 2. Okay, hope that's all right for you. Please do add a comment below if you're not sure about anything. I'll always respond to you. Have a look also on the channel, on the playlist. There's quite a few videos that will cover some of these areas as well. I hope it's been useful, and I look forward to seeing you inside video number 4, where we're going to complete this paper.